One more Lewis Dot diagram. This one's a bit different because we've got a lot of electrons, more than you'd expect to deal with. This is bromine pentafluoride, a molecular substance, and we use that naming convention with the mono, di, and tri to indicate that this is a covalent structure, not an ionic. If it had been ionic, we'd have to say maybe bromine Roman numeral 5 fluoride, but this is bromine pentafluoride. And if you count the valence electrons, fluorine's got 7, bromine's got 7, so really it's a total of 6 sevens. If you're good at multiplying, that's 42. 42 valence electrons. That's the most we've dealt with so far. So these are going to be a lot of dots. Well, let's start putting the lines in. And here we've got our 5 bonding lines, which are shared pairs of electrons. That takes care of 10. But that still leaves us 32 electrons left over. We've never had to deal with that many dots around a compound before. So here's what I did. I put those little electrons in, and you can see around each one of these fluorines, it was 6. I just went 6, 12, 18, so forth, all the way up to 30. And even with 30 electrons put around these atoms, there are 2 left over. And look at our bromine. It's already got 5 pairs around it, 10 electrons. But bromine's in the 4th period. It has some d orbital, it has 3 ds, which are very close to the 4s. So you've got really room, because it's a large atom and these fluorines are small. You can put them around here and stuff these electrons there. And here's our 2 extra. And I'm going to try and find a location for them right there. There we can put them in. So even if you have a situation where there are leftover electrons and you already have an octet, it's fine to put those extra electrons in the center atom. In fact, that's what you're supposed to do. That works out best. But this will usually only end up happening for elements that are down here in the higher periods, because they're large. They've got large energy levels with room for many electrons, more than 8. So this is our Lewis dot structure, but let's analyze it a little bit more. And here you can see we've got 5 shared pairs around our bromine. And we have 1 lone pair, and that creates 6 domains. Now that type of structure is very interesting. We'll deal with structures later, but this is roughly what it looks like. And here's another diagram showing the fluorine sort of in a 3-dimensional arrangement, with that lone pair down here, which really actually would take up a little bit more space than that. Typically, these lone pairs are supposed to take up more volume. The pentafluoride stuff is very interesting. I went to Wikipedia and found out a little bit more about it. This is something that they use in making nuclear weapons. And it's bad enough all by itself. So I guess if you're working with nuclear material, working with a substance that is corrosive to the skin, irritating eyes, mucous membrane, creates a toxic smoke, reacts violently with water, and is lethal up to 100 parts per minute for almost any creature exposed to it for a minute. So that's our bromine pentafluoride. But here we are. We've made the Lewis dot diagram with it. We had our pencil and paper, and this is just using this simple arrangement of counting dots lets us figure out what this molecule looks like. Okay, there's our Lewis dot diagram.